Hello, welcome to the Chong channel. So right now we're going to talk about how do we factor quadratics, but in an interesting manner. So the following problem reads, which expression represents the width of the rectangle? So if you look here, we have a polynomial, or in this case, more specifically, we call this a quadratic, x squared. Anything with an x squared or a variable squared, that is called a quadratic. X squared minus 4x minus 12 is inside this rectangle. So this is the area. Now let's think back into middle school for a moment. If I wanted to find the area of a rectangle, how would you find that? What? Did you say length times width? Absolutely correct. So let's call this length, and we'll say this is the width. So in order to find the area, we're going to multiply the length and the width. Now in this particular problem, we already know what the area is. And we actually do know what one of the sides is. It's x plus 2, but we don't know what the width is. So just like we learned in multiplying polynomials, we're going to think of this as the multiplication box problem. So let me just rewrite this. This is x squared. So that's the first term, goes first. Now if you remember, here we have x plus 2, and then the last term is negative 12. Now, some of you are wondering, why didn't she copy down that negative 4x yet? Well, if you remember in the topic of multiplying polynomials, when we use the multiplication box, diagonally, these terms are like terms, and when they combine, in this case, they become negative 4x. Okay, so first of all, if you remember when we were factoring quadratics, if it was in the format of x squared, x number, or variable squared, variable number, do you guys remember how we factored it? Did you say the x factor? Absolutely correct. Beautiful. So now let's set this up. If you remember, it's last, top, middle, bottom. I mean, in a way, I guess we could have gone straight from this quadratic expression to the x factor, but I wanted you to make some connections later. You'll see why. So a quick review, last, top, middle, bottom. And do you guys remember what that last number represent? Yes, product. Excellent. So let's write this down. Last, top, product, middle, bottom, sum. So once again, whenever we're dealing with this situation, we're going to pretend we don't see the sign. I don't see the sign. So I'm going to start with 1. We're going to list all the numbers that multiply to give us 12. So let's start with 1. 1 times 12. What's the number after 1? 2. 2 times 6 is 12. What's the number after 2? 3. 3 times 4 is 12. And now after 3 is 4, and then the numbers continue. So this is how we know we're done with the list of factors. Now which pair, when you add or subtract, will give us that 4? And it is 2 and 6. So now let's copy this down. 2, 6. Now if you remember, sum is like little brother. Little brother follows the sign of the larger number. Which of these is the larger number? 6. So if little brother is minus, then big brother is also minus. But make sure to check that these two numbers multiply to give you negative 12, and it does, and at the same time adds to give you negative 4, which it does. So what do we have here? If I were to look at this and I went straight from this quadratic to this problem, I have already set up my factors. What did I get? I got x plus 2 and I got x minus 6. If you remember, x times x is x squared, and whatever we got from the x factor, we put that in the parentheses. So these two factors multiply to give us this quadratic. But what do you know? That was our length. So what is our width? Our width is x minus 6. So we have solved the problem. Now, if I were to go back to this situation here, now let me continue and think of this like a puzzle, okay? We already solved the problem. We found that the width is x minus 6. I want you to see a connection here. X times what term gives you x squared? X, absolutely correct. And so if I were to continue the multiplication box, I have x times positive 2, which is positive 2x. Okay. Now, if you look at the situation, if you remember, diagonally, these two terms have to combine to give me a negative 4x. Well, what number is missing here? The only way that I can add to give me a negative 4x would be this would have to be a negative 6x. So now if I were to continue the multiplication box, x times what term gives you negative 6x? And that would be negative 6. And negative 6 times positive 2 is negative 12. And what do you know? Once again, we have found our width. Okay, so I will stop the video here. I might make another video for another example later. Okay, hope that helps, scholars. Goodbye.